So this is a hard question, and I'll start with this condition here and only looking at just the positive. We'll look at the negatives later, but just the positive set of integers. And we know that m and n, their sum has to be 4, 3, 2, 1, and let's say 0 as well. So my choices are, if I list them out, if it's 4, then you have 4 and 0, 3 and 1, 2 and 2, and then 1 and 3. So if I just look at these cases, you'll see there are some of these that won't be satisfied. So I have to also compute this. This product here is 1, mn plus mn would be 0. So that would work. And this one won't, because this would be 3 plus 1 is 4. And here we have 4. So that's not going to work. And this will also not work, because that would be 5 here. And then this will also not work. Now the key thing to note here is that if one of them is 1, let's say n is 1, then these two actually would be both equal. And in fact, or if m is 1, so neither can be actually 1, but also if either one of these is minus 1, because let's say n is minus 1, this would be 1 minus m, and that would be m minus 1, and these two are also equal. Same thing with m being minus 1. So n cannot be 1 or minus 1, m cannot be 1 or minus 1. So that's going to rule out these cases here. So we have one example here, 4 and 0. And we can also get the other possibility would be if the sum m plus n is 3. And again, I'll just ignore the cases where it's 1. So I just start with 0 and 3. I can skip the 1 case, 1 and 2. I mean, I can write it out, but you know that would not work. And then we have 2, 1 is the same, and then 3, 0. So both of these will work, because that would be 0. So actually that reminds me that here 0 and 4 would also work. So my cases so far are 4, 0, 0, 4. So it's really about just kind of observing a pattern. And then next we go to sum m plus n is 2. So again, 0, 2, 1, 1, 2, 0. These won't work, so I get 2 more cases. And then m plus n is equal to 1. So in this case, I have 1, 0, 0, 1. And this would also not work, because anyway, this I've already shown would not work. So we have 6 such cases. Now I have to go on the negative side, because m plus n, if they add up to minus 4, this condition would still be satisfied. And I'll have similar scenarios, minus 4, 0, and then minus 3, minus 1, minus 2, minus 2, and then minus 1, minus 3, and then 0, minus 4. These would be out, and those also won't work, because this would become 5. So again, we're left with just minus 4 and 0. And so if you keep doing it, the same logic, you will also get 0, minus 3, 0, 0, minus 2, and minus 2, 0. So you get 6 more cases. There's a total of 12. So yes, I mean, I'm not sure if I would actually get this right in the exam, because under pressure to look at all the cases and not make any mistakes is very difficult. But this is kind of how I approached it. Maybe there are other ways to do it more efficiently, but this is what came to my mind. So summarize, the answer is 12.